This is section 2.2. And the first question asks, state the intervals on which the given function is increasing, decreasing, or consistent. In this case, it is increasing, and this is on the x-axis. It is increasing from negative infinity to positive 2 on the x-axis, and it is decreasing over here from 2 to positive infinity. Our second question, determine whether each of the functions is even, odd, or neither. So what we're going to do for this question is plug in both 1 and negative 1. When we plug in 1, we're going to get equals 2 times negative 1 squared plus negative 1 plus 1, which ends up being 4. And when we plug in just 1, 2 times 1 squared plus 1 plus 1, which also ends up being 4. Now, because these answers are the same, we're going to get an even function, and that is the answer for question number 2. Number 3 asks us to evaluate a piecewise function, and we've got if x is less than 3, our equation is 2x, and if x is greater than or equal to 3, our equation is negative 5x. So first, f of negative 1, we're going to use the first equation, 2x, that we're going to get an answer of negative 2. F of 3, x is greater than or equal to 3, so we're going to use the second function, which is the second equation, which is negative 5x, and that's going to give us negative 15 as an answer. Finally, f of 10 is obviously greater than 3, so again, we'll use negative 5x, and that gives us negative 50 as an answer. Now, what we're going to do in order to graph the piecewise function is create a little table. So we've got negative 1, when x equals negative 1, y is negative 2. When x equals negative 2, y is negative 4. When x equals 0, y is 0, and so on down the line. And that is for our equation 2x. And with our negative 5x equation, when x equals 3, y equals negative 15. When x equals 4, y equals negative 20, and so on. And then we can actually plot these points and see a trend in the graph. Now, in order to graph all these accurately, because my numbers for y go all the way up to negative 30, I've made each of these units equal to 3, so you can't see it very well. But our function comes here, it increases. In the bottom, this is negative 2, and then we jump up where it increases, but at a steeper slope. I believe it's, let's see, 5 over 1 is the slope here. And it increases at a steeper slope for negative 5x. So that is the third problem. Finally, for each function, determine and simplify the following. We've got f of x plus h and f of x plus h minus f of x over h when h does not equal 0. So first, part A, we're just going to plug in x plus h. So 9 equals x plus h squared, which gives us x squared plus xh plus xh minus h to the second. 9 minus x squared plus 2xh, we combine like terms, minus h to the second. So that's part A. Part B, we're going to plug it all into this equation, and we already know f of x, which is 9 minus x squared. So 9 minus x squared plus 2xh minus h squared minus, parentheses, 9 minus x squared, which gives us 9 minus x squared plus 2xh minus h squared minus 9 plus x squared all over h. The 9s are going to cancel out. We have a positive negative. The negative x squared and positive x squared divides out, and we're left with 2xh minus h squared over h. Pull out an h from this, those divide out, and our final answer, simplified, is 2x minus h.